create a sequencer, increase documentation, and start programming with pseudocode. We also wanted to learn new skills from our FTC parent team. We asked them to teach us about fundraising and the engineering design process.
The process is easy to remember. Big robots pop footballs or brainstorm, research, prototype, final build. We brainstormed two unique ideas. One utilizing a dog ear, the other with a wall that moved along the X and Y axis. Through research and prototyping, we found a combination of the two was best. Before the final build, we used CAD to help us discover any issues.
We split the table into 3 sections, which helped us decide which mission would go in each run. We have 11 missions for a possible 460 points.
We use 4 motors and 7 sensors, 1 gyro, 2 color, and 4 rotation. Color sensors are used in a line find and line base my blocks. The gyro helps turn and move the robot. Our rotation sensors report back the speed and position of each motor.
We used 5 attachments: a powered cargo connector, the PCC, a long arm, a forklift, a cargo holder, and the truck lift. The PCC and long arm are used in Run 1 to accomplish 7 missions. The forklift and cargo holder are used in Runs 2 through 4 to do 4 missions, and the truck lift is used in our last run for 3 missions.
An innovative feature is that we can make repairs by removing our wall via only 2 pins.
We start each run with calibrate. First, the robot drives backward to square to the wall. Then we reset our angle, reflect, wheel motors, and other variables and lower the wall to the 0 position.
We created 22 my blocks. Some increase our accuracy, for example, line find and line base. Others streamline programming, making it so that we don't have to duplicate programs, and not only simplifying it, but also making changes easier.
We compute our own angles so we turn and drive more precisely. We do this by taking our angular velocity and multiplying it by our timer. We also reset our timer 50 times per second. This allows us, we also have 3 sequencers. These are variables that allow us to change the same number multiple times with ease.
To document changes and improvements, we use Google Sheets and individual notebooks. Some iterations are simple, like adding a long arm to an attachment to do bridge while driving by. Other iterations are not so simple.
The first attachment we made for the sorting center had several iterations, but in the end we scrapped it. That was impactful though, because we were able to take that knowledge and build a new attachment. Another big iteration was taking our XY robot and changing the slide to a dog.
Since we switched to spike crime and needed to learn about its capabilities, testing became really important. We attached a marker to our robot to track its path and check its accuracy. We changed things such as driving with power versus speed. This helped us figure out how to make our robot drive as precisely as possible. We also tested the robot's performance with added weight.
We wanted all team members to feel included, so we came up with leaders for each area. Connor is creative, thorough, and a very natural build leader. Nora loves to program and doesn't leave things unfinished. Anam heads up core values because she loves team building and motivating others. Cora and I are project leaders because we come up with creative ideas and love a good challenge.
At the end of the day, we always encourage others to do their best and help others when needed. This competition is lots of fun, and we're very excited to compete today. That is the end of our presentation. Do you have any questions?
Telling you guys we're paid to have questions.
Oh, yeah, we got one.
Oh, wait a minute, we didn't get paid, did we? We still have questions, even if we don't get paid. So thank you for that. Dan usually takes most of the honor.
Right.
So I get my couple of minutes here.
Okay, so I'm going to start with mission strategy, just because it's at the top of the rubric. You said you had 11 missions, how many times do you launch the robot in base?
About 5 times.
5 launches, okay. And you split the table into 3 sections. Why did you divide it in 3?
To make it so we Nora. But so we can have it we can run the robot in the most efficient way using the least amount of time and like the less amount of time home.
And then
Okay.
we don't have to travel to the other side, like the whole other side of the table multiple times. We only have to go there once and then do all the missions that we can complete over there. And then on the other side of the table, we just have to launch it one time over there. So then it's easier and it takes less time.
Okay. And then how did you decide, so you didn't do all the missions, how did you decide to do the ones that you actually
Well,
done?
so we divided them into easy, medium, and hard. And for regions, we kind of attacked the easy missions and the medium missions for the robot that we had chosen. And then here for state, we expanded our run and grabbed some of the hard missions and then just added on and tweaked and stuff.
So I'm going to ask you, what did you use to determine whether or not a mission was easy?
We kind of just like,
What makes a mission easy?
Well, it depends on the attachment sometimes. So sometimes things just need like a finger that we can attach to our robot and then it can just do that. Or sometimes it's really hard to get into an area because it's really small and compact and tight. There's things all around it, so then it's harder to get to an area. Or it's just with the robot that we have, there's obviously some things that we can't do because we don't have enough motors to do everything that we want.
Right.
But so it just depends on those things.
We
It
also
depends partly on the robot and
Yeah.
then are there any other considerations? Because there's a lot of different ways that some
Yeah.
mission can end up being hard.
We also because we did this before we built our robot.
Yep.
So we pretended to be the robot.
Sure.
And because we can easily do all those missions on the board, but that's because we're humans and
Mhm.
we have all these different joints and stuff. So we pretended to be as stiff as the robot was, and that helped us figure out how hard it would be to get into specific areas.
And we could also do prototyping of attachments.
Okay.
To do that.
So who did what? Like for all the different missions, did you have like mission teams or did you like try one thing at a time? How did you decide how to do the work? There's a lot of work to do, right?
So yeah, we came up with an agenda for each meeting, so that's what we absolutely have to get done that meeting. And then we just split up into what we wanted to do, and nobody was a designated like you always work on programming or you always work on build. We all mixed it up so that we had like a well-rounded team.
Okay.
And so because nobody specifically worked on one thing, we all worked on all of the runs.
Do you think that helped?
Yeah, I really think it did.
Is there like something where somebody else coming on to work on it had added ideas that the other person hadn't thought of?
Yeah. That happened a lot.
Okay, you mean one time?
Well, so here's one attachment. So Connor worked on this, which is for the sorting center, and
Sure.
it had originally 3 of these things on here, and then
Somebody came along and
we changed it to
developed
this,
this,
and then we had to
somebody
adjust it
else
to
made
this.
this.
Okay,
I'm the build leader, so
okay.
I do a lot of builds.
So what do you think is the most innovative thing about your robot?
So
There's
the
one.
we can take our wall off of our robot, and last year our robot was also an XY robot,
Okay.
and but it was much bigger, so this year we had to take into consideration that we were gonna have to make our robot smaller because the table was a little bit harder to get to certain places. So on the bottom of our robot right here, we have these little pins which keep in these long axles, and if we just take that off, we can just take our whole wall off and get inside or do things like that.
You can
So it's
demonstrate
really
if you want.
Sure, sure. And then the other thing I would ask is if you have any examples of your code. 'Cause
Oh,
we've
yeah.
looked a lot about the robot, but not about the code. Okay. And you have to take that off in order to do another mission?
No.
No.
It's just in case, like the gears in here break,
Okay,
or, we need to switch out our gas or add, or do some service on the stop gear. It's just super easy to take off.
Okay.
okay.
So now when she does a little coding, if they do a little
Sure.
coding here, I'm gonna just ask a couple other questions because it kind of lets us get more doing it. So, what would you guys say was the most challenging thing you had this year?
Probably switching to the new programming type because we had EC3, now we changed to Spike Prime. Now it's a whole different code, and we had to learn how to solve problems
Sure.
that we had known how to solve before.
Okay. You're not the first team I've heard say that, but that was a big challenge. What would you say is the most important thing you've learned this year?
I think the most important thing that we've learned this year is how to collaborate together over here because we figured out last year that we were a team that came to a consensus quite easily, but with Zoom and all that stuff, it was
Sure.
really hard to become like
Okay.
a team as a whole and work together really well. And so I think we learned like how to become better friends and just how to help each other and what our strengths and weaknesses were.
Another skill we learned is fundraising because we didn't have any support this year from our schools. So we had to go to our neighborhood and then fundraise and gain money, and we learned how to do that.
Yeah, and we got $1,030 from 13 donors.
So you said that you had an FTC team that guided you. Who's your FTC team?
The devil dogs.
I know who the devil is.
And
I've judged all the FTC teams though, so that's easy for me to say. So besides working with the devil dogs, were there any other
So do you have
teams
a
that
main
you worked
program?
with or interacted with?
Yes, we
Like the
did.
calls all
We
your different moms?
worked with another Leicester Park team called Jeffy,
Okay.
and they gave us some programming, and they didn't unfortunately make it to state, and so they actually let us use their brick for their robot and all their pieces so that we could make Eve our second
Okay,
robot.
so you have program A, B, C, D, and E. So then that writes to the screen so that the person running the program can see what it is? Yep. Okay. Do you always run the runs in the same order every
Yes.
time? Okay. So what happens if
So you said
a run
that
messes up?
less support out of school or whatever this year for doing that, was it something that
Okay.
changed? Is it just that you're a different grouping? How did that work out?
It's because we're in sixth grade for middle school, and then we'll have a sixth grade team.
Ah, so you went from
and then change the sequence.
the elementary to the middle and it
Yeah,
was
and
changed
we
for
went
that.
from
So you
school
write
to
that code back
neighborhood,
to
and
the main school.
the
You use that in
Double
your
Dogs
single
actually
robot?
kind of took us under their wing, and they
So
helped
this
us out
says
a lot,
right
and
A,
we
right
met
to
in the
the
same
school.
place
Do
that
you use
they
that
did,
anywhere else within the program?
and it was a lot
Okay.
of fun just having that
Is that
conversation.
something that sometimes you can use to like let the user know where the robot thinks it is too? So
Yeah.
it helps with debugging sometimes.
Yeah, sometimes if my robot isn't working,
He's
we'll
taking
check,
long reading to remove
have
that.
it go to the spot and it'll let us pause it, because we have a pause button.
Okay, show me that.
I'm just making sure
Okay,
I've asked you all the
using
questions I
beeper.
wanna ask you.
But, and then it's waiting
Until you press
until
it.
we press a button, and so then we can go and check our moves.
Let's see, so should I pick on your mentors
Sure.
or something while they're doing that?
Makes it as
Yeah, I love to pick on mentors.
I have something to say about the programming.
Okay, so
So
does that?
actually,
when you go
all of our
pause, does it
program is
display
basically
things on
just
screen?
my blocks.
No.
And so that makes it so that if we change something in a my block, we just go over and change it. And instead of like using movie blocks or something, we don't have
So
to go
if
to
you're using
every
the
single
buttons,
program and
there's
change it. It
you
just
should
changes
have it put all
automatically
the
to every
sensory
single one
information
because
on
that's
the
our
screen,
block.
like immediately,
And was
because that's
that
what
you
you put
who
it in
learned
there
this
for.
year?
No, we used my blocks in EB3,
Uh-huh.
and so we just adapted
Was
like
adapted to
Prime
it.
and
Yeah, that's a
used
lot of
my
my
blocks.
blocks.
Yeah, we put it somewhere.
All right. So, I'm back to you. I have to make you ask questions, get them ready. I got most of mine done.
30 seconds. Let's see. Yeah, nice job with the engineering design process. What do you think was the most frustrating thing that happened this year?
Spike Prime, and then we knew all of the little things about EV3, and now we are switching to Spike Prime, and we didn't know a lot of things about it, and then we had to test a lot to figure out how Spike Prime works.
What do you think is better?
Probably Spike Prime, because EV3 had a bunch of confusing blocks. It had symbols, but the symbols had like nothing to do with it. There was like one block, it looked like a suitcase, but for some reason helped help the gyro. I don't know where that came from.
So I would say that
probably.
there's downsides to both of them, but then there's also things that are better about other ones. So we weren't really sure which one was going to be better, but then we just decided why not try something new. And so then we tested it out, and we like Spike Prime, but there's also, of course, some downsides.
Yeah, like with the gyro isn't ultra accurate. Not that it wasn't EV3 either, but our wrapping paper test definitely told us that. And we also learned that whenever we tell the robot to go to 90, it goes to like 93. So we have to set, if we want to go to 90, it has to be set at 87.
Oh, we should.
And that helped out a lot.
Okay,
And
I do actually have to stop you guys. When his little alarm went off was actually when we ran out of time for you. Otherwise, we could talk all day and eventually we get judged all the way. But congratulations on making it to state.
Thank you.
Awesome. You can tell the devil dogs that the lady from Robo Sharks says hi, because they were actually on one of our alliances.
Oh, yeah.
And good luck on all of your stuff today.
Thank you.